In this video, I'm going to discuss how to use workflow scripts to run a command line and to get the output from that command line to do something with it. So I'll show you a couple different ways to do that. Well, a couple different methods that we use to do that. But first, I just wanted to give you a quick correction on the previous video. Two things that I think I missed in the previous video. One, I think I added this line right here without telling you what it was. And what this is in my logs, I use vlog in my functions to write out log files, which means that I have to pass in vlog, which you saw. But some of the functions that we added to our script use script log, which is a public variable. It's defined up here at the top. That way you don't have to pass in to use the logging. So here we set script log equals vlog. That way it's implicitly set to this object. It's referencing that object so that we can use logging without having to actually pass it into a function. So that's what that's all about. If you had forgotten to put this here, then your edit HL7 may not work when you call edit HL7 because it uses that logging. So I just wanted to mention that in case I neglected to mention it before. But moving on, so we are going to try to do some stuff here with the command shell. And just to give you an idea of what we're going to do, so let's take an example. So I'm going to run the ipconfig command, right? It's a standard command in Windows, and it outputs information about your, I mean, you guys know this, it outputs stuff about your IP address and your Ethernet cards and so forth. So in order to do this, right, so in order to run a command, our first step is we have to create an object called process. Well, not called process, but that is of the process type, and that's going to let us call the command line. So first we have to create a new, and I'm just going to call mine ipconfig. I usually, when I create these, I just make the name of my process, the name of the command that I'm calling from that process. So that's why I'm going to call it ipconfig. That way I remember what it is. So this is going to be a new process, which is an object. Next, now that I have this object created that's of a process type, right? Process is the type that it is. Now I can do stuff with it. So for example, start info.filename is just going to be the name of the command. So it doesn't actually have to be a file. I think this works. Let's give it a try. I don't think you have to put the full path to ipconfig. So I'm just going to try it like this and see if it works. All right, next, arguments. We might want to pass some arguments, but we're not going to do that for now. I'll do that later. We're just going to do a real basic example here first. So then you have to put a couple other things in here. So we're going to do start info dot use. This is a property. Use shell execute equals false. So we're going to redirect standard input. We're also going to redirect standard output. This allows us to use the standard in and output from the command line. All right, and finally, create new window is going to be true. Sorry, create no window. I think I said new. So this is true. That way it's not trying to open up a dialog or a new window. Since we're doing this from a service, that wouldn't work if it tried to open up a window because it's not running in a user space. And then we're just going to go ahead and run the command. So if I just do start, that's going to execute the command using all those parameters that I provided. So oh, I spelled info wrong here. So this is going to pass it this command. It's going to say run this command. That's the file name. Don't use shell execute. Redirect standard input and output. And do not create a new window. And then start the command. So once the command runs, there's a few things that we can do here. One is we probably want to look at the output, right? We want to capture that output. So actually, I always like to put the L in front of these. So I'm going to create a variable called output as system.io.streamWriter. Is ipconfig.standard output. That should be the standard out from that ipconfig command that ran. All right. Then we're going to close the command. So to close it, we're just going to use .close. Oops, I almost forgot. It's standard input that we're going to close. I have to spell it right. Sorry about that. Standard input. .close. If you're wondering where I'm getting all these properties from and these methods, they're all documented if you look up the process library in VB.net. All of this is documented, and they have examples that show you how to use this. But that's where I'm getting all that from if you're curious. We should probably output something in the log at this point. So let's see, we're going to output here closed, oops. We closed our ipconfig command. And we're going to return, we're just going to say true. Just so we know we did something here. And the thread I'm going to call process. And it's a 0 because it's just information. All right, so we close the command. Okay, now we are going to use our output. So while L_output. Oops. So while we have some output to work with, we're going to create a variable called line, right? This is one line at a time it's going to output as a string. And that line is going to be the next output, the next line that we read from L_output. So basically, L_output up here is basically the standard output from that command. And this line here is telling us while there's still lines left, read in the next line. And of course, we want to probably show that line to somebody in the log, so I'm going to add a log entry. I'll just copy this one. So we'll just put here next line. There we go, so that'll just output the next line. I probably should put, I always try to stay in the habit of putting L_ on my variables. That's it. Then we go to the next line. So all this just to output the ipconfig command. So let's give this a try. I'm going to save it. And let's go ahead and restart our service. I'm going to keep an eye on the log files and see if we get any output here. We're also going to check this one, see if we get any compile errors. Looks like we got a compile error here. So it says here, where is the last one that started? 1717, that's right now. Custom process compile error on line 39. And it says break script is used before it has been assigned a value on line 39. So let's take a look at that. Oh, that's not right now. I think that was a an old compile error, because right now it's 539, and our last compile error, oh, here we go. Now we've got a bunch of compile errors. So process is not defined. While must end with a matching end while. Oh, you're not supposed to use next, use end while. And all this stuff breaks because we didn't declare process correctly. And I'll show you why in a second. And then what are the other lines here? Line 113, 120, 123, that's all mrest DICOM not being declared, probably because I'm trying to use it in a function. So let's go back. So I believe, yeah, so we had created these functions earlier that use mrest DICOM, right? But that doesn't exist, so we have to add that. It's because I took it out because we weren't using the DICOM stuff. So I'm just going to go ahead and add it back in. That way we have it. So let me do that first. And that should get us, so I'm going to put back in our Ultra DICOM stuff. So this is the basics that we need for Ultra DICOM, if you recall from before. And then inside our script, we need to create the object for DICOM. There we go. All right, so now that we have that in there, that should get us to some more relevant log lines. So let's start the script. We'll keep an eye on the log file and this one over here as well. Okay, we already got some log entries here. So it says here that process is not defined, while must end with end while, and then we've got some errors here with number one, it doesn't know what next is, it doesn't know what end of stream and read line is, because that all relates back to process. So if we look in our script, we create an object here called process, right, using process, the process class rather, and this, since this is not defined, it doesn't know how to do this, all of this stuff is going to break. So none of that's going to work. The other thing is down here, this should be end while rather than next. So I got that wrong. So that syntax was wrong. So that should fix that error. But again, we still have the problem of process. So I'll show you how to fix that. Process, we have to import a library in order to use process. And I believe, if I'm correct, let me double check. But I believe that's going to be system.diagnostics. So let's try that. So imports system.diagnostics. And then we'll try starting our service. And we'll keep an eye on our error logs over here. So it's 1742 right now. And I don't see any new errors yet. Oh, here we go. So now we've got a bunch of errors. So it's 1742. We got system.io.streamReader cannot be converted to a stream writer. And then we also have end of stream is not a member of stream writer, and read line is not a member of stream writer. So it looks like I got something wrong with stream writer. So let's take a look at that. Well, I think this is a relatively simple problem. I think this should be stream reader, not stream writer. It would make more sense that we're using stream reader to get standard output. Stream writer you would think would be some kind of input, right? So let's give this a try and see if we get a little further. All right, just gonna refresh the logging over here. Check and see if we have any compile errors. Oh, here we go. Oh, that worked. So you can see that it output the line from all the lines from ipconfig. So our next step here, we're just calling ipconfig, but we want to put some arguments in there because we want to play with some of those arguments. We want to be able to pass in arguments. So to do that, we use another property. So I'm just going to copy this. And if I had to hazard a guess, I think it's just .arguments. And it's going to be /all, right? Because when we run ipconfig with /all, we should get some more data. Just waiting for it to start. There we go. So this time we got a lot more information, right? So now it's giving us, it looks just like the command line, right? It's just outputting the result from the command line, and that's it. Now let's say we just wanted to get the MAC address, right? The physical address. If we just wanted to get the physical address, let's play with that a little bit. I'm going to show you how to use some loops to figure that out. So for each line, right, so we're going to get these one line at a time. If we wanted to try to parse out whether or not we have the physical address, what I would want to do is I'd want to check to see if the string has physical address in it, and then see if it has, and then extract just that value. So the way I would do that, so let's go back down here into this while loop, right? So instead of outputting each line one at a time, this time I'm going to try to split the string, right? So we'll do a dim parts as string. So we're going to make an array just like we learned before. And we'll do, we're going to do L_line dot split. And I'm going to split on that semicolon, right? Because the semicolon splits the different parts of that output in the command line, so it's predictable in the output. So I know if I always split on that, I should get two parts. I might get only one part because there may not be, that character may not exist, so it won't split into anything. And then I can process that one part at a time. So for each part, oops, I've spelled for wrong. So each part, which is a string, in parts, all right, so it's going to take the parts array, and for each part in that parts array, which again was split on that colon, I can check, right? So we're going to do an if statement. We're going to say if, and we should be able to do a search in our string using a string function in VB.NET. So this is from .NET Perls, and it shows us the syntax for the index of method, right? So we do string.indexOf and then whatever we're looking for. And if that is a, if it's contained in the string, then it's going to output a -1. Okay? So we can check to see if it's in that string. If it's not in the string, then we'll have a different output. Let's see another example here. So here we say, here it's a string that's you have a cat. And if it contains the letter A, right, the character A, then it's going to tell us the position in that string. So we should be able to just to check to see if it has that character in it, right? Oh, by the way, it says not, so that's why they're checking -1. So if dog is not in that string, it's going to output true. We want the opposite, though. We want to make sure it's greater than 1, or sorry, greater than 0, because that'll tell us that it's or greater than -1, really. If it's greater than -1, then we know that that string contains the value. You can see up here that it says that if the string is not found, the result is -1. If it is found, it's going to be 0 or more. So if we know it's greater than -1, then we know we have that string. And that's what we're looking for, right? We want to see if we have a string. So let's give that a try. So if the part dot index of is greater than -1, we have a match. But we have to tell it what we want to look for. So in this case, since we're looking for the MAC address, we're looking for physical address. All right, now I have one thing wrong here. I probably don't want to check this inside the loop. So let's move this. So we're going to do this first, right? So first we're going to check to see if the line has the string physical address, right? Because here it is, it says physical address. Then we're going to create we're going to split. And then I want to make sure that it doesn't have physical address. So I'm going to copy this. Oops, this should be line, right? We're checking the line first. Then we're going to check the part. So let's come down here and check our part. And this time, I want to make sure it's not greater than -1, right? If it's not greater than -1, or I'm sorry, we do want to make sure it's greater than -1. If it is greater than -1, then we know that it's the physical address, right? So I was right the first time. We want to do not. Sorry to confuse you here. So if it's not greater than -1, then that means that we do not have the string physical address, which means that what we actually have is the MAC address. So now I'm going to output the MAC address. So one of our MAC addresses. And we're going to show the part. Now the problem is, part is going to have all kinds of junk around it, right? So if you look here, there's a space on the front of it and a bunch of spaces on the end. So I think we want to do .trim. Hopefully that works. We can check .NET Perls to see if that's a valid function in VB.NET. Here it is. So trim will get rid of all that empty space, all the white space that's around our string. So that's exactly what we want. All right, now we have to end our if, put a next in here for our for, and let's see if that works for us. So it looks like we have a compile error here. You can see that it says here on line 50 we have a compile error. Yeah, if must end with the matching if. So if we go back to our script, here we go. So there's our line 58. So we have an if, but I accidentally put a next here. So we're going to use an end if instead.
No problem. Yeah, let me just walk into Matt's office. I'll have him switch it back and you guys will be all set.
All right, so the script restarted. And you can see now I just have MAC addresses. All the rest of this stuff is filtered out because it's only outputting where we have a physical address. And just to review that code, basically what I did, there's more than one way to do this. This is just the way, oh crap, I just spilled soda all over myself. But this is the way I chose to do it. I started with I checked to see if the line contained physical address. And if it did, I knew there was something in there I wanted to extract, which is the MAC address. So then I used I exploded that string into an array, to a multi-part variable, right? It's a variable that contains a list of things. In this case, it's a list of each thing separated by the colon. And I checked to see if it's physical address, I know it's the part that I don't want. So I checked to make sure it does not have physical address in the value for that item, and then I assume it's the MAC address, so I just output the MAC address with a trim so that I trim off all the spaces around it. And you can see here that it worked perfectly. Like I said, there's different ways you can do this, so you could probably brainstorm some other ways to output values, to output things from this command line. But this is a good little practice that you can use. Maybe try extracting some other value in this list, or maybe multiple values, maybe some other things that you want to look for in this list. So this was kind of useful. We outputted a standard command, but a lot of times we want to do things with files using other tools, right? We want to pass in arguments for other things. So for example, I've got in my system under Ultra Workflow, I created a directory called DCMTK, and this is the Office Toolkit. I just got a few commands in here. One of the commands is store SCP, which I'm sure you guys are mostly familiar with. This is for receiving DICOM files. And then we have store SCU for sending DICOM files. So as an example, I'm gonna run store SCP. So let me do this. I'm gonna create a directory. Called DCMRX. And I'm going to run store SCP from inside that directory. Okay, and I'm going to listen on port, let's see, -V for verbose, and I'm going to listen on port 4000. All right, so I've got store SCP listening on port 4000. So now I can send studies using store SCU to port 4000. And I'm going to put up another command line just so we can figure out how to use that command. Oh, I thought I opened another command line. There we go. All right, so let's go into oops, I got to get the Ultra workflow. Long way to go here. Hold on. There we go. Okay, so now we're going to run store SCU. That'll show us the options. In this case, we want to do we want to pass in the peer, the port, and the file. So the peer is going to be 127.0.0.1. That's our local loopback, port 4000. And the file, in this case, just to give it a try, I'm going to go back to my good old file in, and we'll try to send that file. All right, now we got an error message, right? It didn't take it, and probably because it didn't accept the, oh, here we go. It can't change the syntax from JPEG lossless to implicit little endian. So there should be a command line switch in here to change that. So we should be able to, there we go, XS-XS should let us send it as JPEG lossless. So let's give that a try. All right, now it looks like store SCP did not accept it in that format. So let's see if store SCP has a command line switch that will accept it in any format. Let's see. There we go. So we're going to do +XA, which is accept all transfer syntaxes. All right, so +XA. -V for verbose, port 4000, come back over here, and it worked. All right, so if I go into my RX files, DICOM RX, there's my file, which is exactly what I wanted, right? I wanted to be able to send a file. So now that we know what that command line has to look like, let's try to do this, run this same command, but do it from here, right? So this is going to be a little bit different. We don't care about the output anymore. So I'm going to go ahead and get rid of all this output. Right? None of that really matters now. Obviously, in something you guys might do, you might want to have that, but I'm not really concerned about it. And then this is no longer ipconfig. Now it's going to be store SCU. Now, the other thing is, when I do this, I like to create a variable to contain the path to my command. So I'm going to call it store SCU command. And I'm going to put the path to that command. That way I only have to reference it up here at the top. So if anybody ever wanted to modify my script, they would not have to actually go into the script. They could just, oops, I spelled store SCU wrong. I just want them to be able to change whatever they need right here at the top. Makes it easier for users when they have to modify your script. Okay, so now that we have that, right? Now we have our store SCU in here that we can reference. So I'm going to change to that in here. So instead of putting the actual command, it's going to be store SCU. Now here for the arguments, here I am going to put in 127.0.0.1. Actually, I have to put in some, let's see what those switches were. So it's -XS 127.0.0.1 4000, and then the path to that file. So let's just copy this to the clipboard. All right, so that should pick up our file and try to route it. Now there's one more thing I want to do here. Instead of just closing, right? So I could just close this script, but instead I want to see the error code when it completes, if there was an error. I want to see how it completes the command, right? Did it actually work, right? That's what I'm interested in. So we're going to do v_log .write event. Store SCU result, and the exit code is going to be a property. So that should tell us how the command completed, or if the command completed. So let's go ahead and give that a try and see what happens. Oh, first, let's go into our RX and delete that file. That way, if it worked, we'll see it show up. Still waiting for it to start. And I don't see any new log lines here, so I'm going to check over here and see if we got a compile error. The system time is currently 6:11. There it is. So store SCU is not declared. So let's go back and look at our script. I thought we declared it. Oh, I forgot to put an E on store SCU. So I referenced it in a bunch of places without that E. It's always these little typos that'll get you. All right, let's go ahead and try this again. Just waiting for the service to start. All right, here we go. This time we got an exception. Process must exit before requested information can be determined. So it looks like I got to do a dot close, I think, on this. So after the dot start, we probably need to do a dot close. And if this doesn't work, we could also wait for an exit too. All right, we got an exception again. It says no process associated with the object. So this is what I think is happening. Is that it's not actually finished yet when we try that dot close. So instead, we can tell it to wait for it to exit for a period of time. And if it doesn't exit, then it'll force it to close. So basically what this is doing, I'm just going to put 5 seconds. So it's going to say wait up to 5 seconds. And if the process is not closed after 5 seconds, then forcibly close it. But if it is closed, then it'll just move on to the next step. So it'll just either wait for it to close or when it's closed, because this cannot run until the exit happens, right? There has to be an exit before it can tell you what the exit code is. So we'll see what this does. Hopefully it doesn't take 5 seconds to run. So let's restart this. And we're going to wait for a new log line. It's 1814 right now on the system time. There we go. So it ran this time. And notice it took at 396 is when it started, and at 897, right? So 396 it started the command, and then at 897 well, maybe not right at 396, but pretty close to it, because it wouldn't take that long. And then at 897 it outputted the result of the command. So it's close to probably a quarter of a second, but without that wait, it goes too quickly to try to show the exit, which hasn't happened yet. So it didn't wait a full 5 seconds. It waited it just waited until the command closed. So that's not so bad. So that worked. So now we were able to run store SCU. Now with this basic script, between what I did in the previous example that you wrote and what I did just now, and with everything else that we've already done, what you should be able to do is write yourself a little script that basically loops through all the files. So let me go back over to our file in. We should be able to loop through these files, and we should be able to have store SCU send each one of these files. Now, I'm going to do one step better than that. I'm going to ask you to do something a little bit more comprehensive than that. Now, first, I just want to show you what happens if we don't pass this correct command line here, right? We know this is a lossless image. Oops, let me restart the service so we can see this. Okay, so notice what happened here. When I made this change, now the result is a 1. 0 means that it worked, right? 0 means there's no error. 1 means that it returned an error. So something went wrong. So we can use that, right? We can catch that to see if there's if we have to do something else, or to see if it actually worked. So in any event, let me go back to another thing I wanted to show you is with store SCU, we can send more than one file at a time, right? So I could do, instead of just sending one file, we can do star.dcm, and it should try to send all the files. Now, of course, it just failed because we need to add the oh, wait a minute, let me see. Oh, we did add .xs. Oh, this image that I have in here is probably not, let's see if there's JPEG 2000 in this list. Here we go, JPEG 2000, so XV, so I have to pass XV, because I think these images are actually JPEG 2000. There we go. So it sent some of the images and then it failed, right? So so we can pass, a wildcard to send a whole bunch of files if we want. But in any event, let me, I just want to show you some of the different options. So I use different switches for different. XV was for JPEG, XS was for JPEG 2000, which I just referenced up here, right? So there's a difference we could try. So this was lossless was XS, XV was J2K. There are some other ones in here, but those are the common ones, right? So usually by default we try little endian first and so forth. All right, so now that you have a little bit of a background on how to use the command line and how to go through those files. So now what I want you to do on your own is try to write a script that instead of just sending one file like I did in this script, embed this inside a loop that loops through all the files. You already know how to loop through files, right? We already know how to loop through DICOM files. We did that before. So now we're going to loop through those DICOM files, but you have to take one extra step. Not only do we have to loop through the DICOM files, but you want to get the study UID so that we're only sending in one association one study UID at a time. Okay, so we want to check to see what the study UID is, and then we want to move that study UID into another folder, that image into a folder for that study UID, and then we want to run SCU. So here's what we could do. Theoretically, we could write a script that just sends everything in that directory, but a lot of SCPs don't like that, right? They want to get one study at a time. So what I want you to do is try to read in the DICOM header for each file so that you know which files are which study. Organize those files into their study folders first, and then you're going to loop through the folders to send each one at a time and make sure you catch any error in case you don't know what the syntax is. In order to set up this test, what you want to do, and I'm going to show you over here. So I created under my files in, I put two different files in here. I put 0 through 15 is one study, and 16 through 30 is a different study. And you'll notice that if you look at anything in my 0 through 15, I picked images that were JPEG 2000, but everything in my second set of images is JPEG lossless. So I've got some different transfer syntaxes here that we'll have to deal with. So two different transfer syntaxes, and in addition to that, I have two different studies. So my solution to this would involve, and you can do this any way you like, but I think the way I would do it, number one, I wouldn't want to just send one image at a time because that's not as efficient. So I would write a loop that loops through each one of these, reads in the study instance UID, creates a study UID folder, and moves each file into a study UID folder. So you should be able to use the directory and the file operations. So there's the directory class and the file class that'll let you create directories, check if a directory exists, and move stuff from one folder to another, right? And again, you can use the study UID. And then when you're done, there's probably a loop that you could write using the directory, using directory, where you can check to see if it's a directory, loop through each directory, and send each directory one at a time. And then you should be able to send all of those images one at a time. Now, you couldn't just cheat and do all of them at once because StoreSC won't support that because you have multiple transfer syntaxes. So you would have to do it one study at a time. If you really wanted to get fancy, you could also separate them by the transfer syntax. So you could have a different study table for each different transfer syntax. But I can tell you that that won't work because the DICOM library that we have does not allow you to check the transfer syntax because it's in the metadata. However, you can check the transfer syntax with one of the Office Toolkit commands. I'm not going to show you how to do that, but if you want to go the extra mile and try that, you certainly could, but I'm not going to do that in my example. So give that a try, and in the next video, I'll show you my solution to that problem.